Hello and welcome. Today in this video we'll be discussing two problems from CSIR UGC NET 2019 and we'll solve two problems, problem 8 and problem 9 out of 55 problem in physics. So here is the first problem. The problem says the infinite square well potential of a particle in a box of size A is modified. So whenever a question is given of infinite potential well, just try to draw and picture what is happening. So initially you have an infinite potential well, okay, of side A, okay, and then it says that is modified as shown in figure below. Okay, so the infinite potential well is modified. So basically you have something like this, and this part is delta, okay, and the height is epsilon. The energy of the ground state compared to the ground state before the perturbation was added. So in this kind of problem, to save your time, what you have to do is you have to understand what is actually happening. Now if you try to solve the equation and find what is the energy and stuff, it will take a lot of time. So in this question, it is very easy to score. Firstly, you have to remember that in second order correction in energy, the energy is always negative. Okay, remember that energy is always negative energy we get for the second order correction. Just remember, for second order correction, the energy correction is always negative. Just remember this. So out of the four option, D is the correct answer. Okay, so we have a problem. It goes something like this: a quantum particle of mass m in one dimension confined to a rigid box as shown in the figure in the ground state. An infinitesimal thin wall is very slowly raised to infinity at the center of the box in such a way that the system remains in the ground state all the time. Assume that no energy is lost in raising the wall. Work done on the system when the wall is fully raised, eventually separating the original box into two compartments. So what we have is, initially for the first box we have the wave function something like this, and later when there is a potential well at the center, the wave function will look something like this. Okay, now in this box, if we look at the nth energy level, we have n square pi square h cut square by 2m 2l square. Now if we take the first energy level, then it will be pi square h cut square by 8ml square. Okay, right? Now in this case, what will be the ground energy? So E2 will be pi square h cut square by 8m. So now the L is L by 2 square because the potential is at the center, so this is L by 2, which will become 4 pi square h cut square by 8m L square. Therefore the difference, or basically the work done, so this is the work done, is given by E2 minus E1, and it is equal to 3 pi square h cut square by 8ml square, which is nothing but the difference between this energy and this energy. Okay, so this is the answer to this problem. So the correct answer is option A. If you like our video, do give a like, comment, and also subscribe to our channel. Turn on the notifications so that you don't miss another upload. And I thank you all for watching.